Hello, it is me, Mr. Gordon. Here's the solution to, what is it? Number 11 on web assign number, 4? Okay, alright, I'm going to try and be a little more definite about the rest of this. Okay, so, a tourist being chased by an angry bear is running in a straight line towards his car at 4 meters per second. Zoop. I'm going to notify that with a V. Note there's no vector hat on top of it because it's just saying the speed is 4.0 meters per second. However, I guess we could make it a vector since it seems to be one-dimensional motion here. But anyway, so here's terrified guy running at that speed. The car, that's the worst. The car is a distance D away, right? The bear is 25 meters behind the tourist. Roar. That's even worse than the car. Oh God. Alright, so it says the tourist reaches the car safely. It says, what's the maximum possible value for D? Okay, so let's take a look at what information we have. Okay, so for the maximum distance, that is for them to basically just get to the car at the same time, we'll say that is the maximum distance that the car can be and still sort of work, right? Okay, for this thing. Whoa! Sorry. Alright, so let's say for person, the average speed is distance traveled over time. And the same thing for the bear. Okay, so but for the person, the average speed is 4.0 meters per second. The distance is going to be D, and the time, let's just make it T. Now, the problem here is, like, can we solve it? No, because we have one equation and two unknowns. You need to make sure that you have two sort of equations. Okay, so can we make a similar sort of relationship but add in the other information that we have? Yeah, it says that the bear is running at 6.0 meters per second. And now, what is the distance that the bear is going to go? I think that we could say that it's D plus 25 meters over T. Now, is this T the same as that T? Yes. When they get there, if that is the longest D can be, that they both get there at the same time, those distances, the times are going to be the same that of the slice of time that we're sort of considering. Okay, so now here was just like a little bit of an algebra trick. Okay, so say 4.0 meters per second times time equals D, and then we can put that in there. So if we were to simplify that, we'd say 6.0 meters per second is equal to, instead of D, we'll put in 4.0 meters per second times time plus 25 meters, all over time. Okay, so now it's just a matter of just doing a little bit more algebra stuff. So we can multiply both sides by T, and we end up with 6.0 meters per second times T equals 4.0 meters per second times T plus 25 meters. Okay, so now we can say, by subtracting both sides by 4 meters per second, we got 2 meters per second times T equals 25 meters. Is that right? Yes, that is right. Okay, so now, what is that saying? Oh, we're almost done. Okay, T equals what units? Please do note how the units cancel out. They should end up being seconds, and we get 12.5 seconds, even though my sig figs right now are a little bit off. We'll wait and keep them all, and then figure it out at the end. But now, is that the answer? Even though I just finished an equation? No, because the question is asking us for distance. Okay, so now what we'll have to do is throw that into one of the equations to determine what that distance actually is. I believe in my example, so I guess that would be 50 meters. Any distance over that, nom 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 for the bear. Okay, hope that helps. Let me know if not.